Okay, good morning, fourth graders. Mr. Tanakomba here again. So this week we are going to be working with fractions, comparing fractions, ordering fractions, as well as adding, subtracting fractions, mixed numbers, looking at some unit fractions, and also changing fractions or mixed numbers to fractions greater as 1. So this whole week we'll be covering fractions. There's quite a few lessons here. I'll try to provide as much information as I can to help you out. So today, the first question is we want to compare 6/12 to 3/4. So as you can see, on the top I have 6/12 and 3/4. Now remember, when we're using models, that there's two rules that we must follow. The first rule must be that they must be the same size and same shape. So for example, I'm using a bar here and a bar here. So they're the same size as the outside and they're the same shape. I cannot compare a model that uses a rectangle to a model that would say use a circle, because they're not the same size and same shape. So, and then the second rule is you got to tell whether the one is greater, less than, or equal to. So let's look here. Let's look at our first one. And let's compare 6/12 to 3/4. So we have 6/12s and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. And so 6/12, my numerator tells me that 6 of these must be shaded in. So let's go ahead and let's shade them in. Okay, so we'll use the color red here. And we'll try to be as neat as possible. Okay, let me take a little. Okay, so 1, 2, 3, 4, 5, 6. Okay, so we got 6/12. We got 6/12 shaded in. Okay, and I'll do something a little bit different here. And then the next one is 3/4. So we'll take 3/4. Okay, 1, 2, 3 out of 4, and we'll fill that in. Okay, fill that in as a solid color. Okay, so now we have 6/12s and 3/4. So we're looking at 6/12, looking at 3/4, looking at their bar models. And if we take a line and we draw it right down the middle, okay, draw it right down the middle, we can see that 6/12s doesn't go as far as 3/4. So in this case, how we would write this would be, would be 6/12s. Okay, fix that 2 there. Oh. 6/12s, would it be less than, equal to, or greater than 3/4? In this case, because it doesn't go as far, it will be less than 3/4. Okay, so that's one way to compare it. And you can use your fraction strips. I included a fraction strip, so if you remember what how the fraction strip was, we used the counters to fill it up. So you can use beans, pennies, whatever you have at home. And you can compare, and all you got to do is look at the ends and see, are they the same? They come down the same place, or is one greater than the other? So here's another way to compare. Here's another way to compare 6/12s to 3/4. So we have 6/12s and 3/4. Okay, 6/12s and 3/4. What we want to do is we want to see, okay, we want to make equivalent fractions. So equivalent fractions. So what we do is ask ourselves is, which denominator can go into the other? So can we say, can 12 go into 4? Let's count by 12. 12, 24, no it can't. Can 4 go into 12? 4, 8, 12. Yes it can. So in this instance, what we'll do is we will leave 6/12s alone. We'll leave it there for the time being. And we want to change 3/4. And we make an equivalent fraction. So remember, to make an equivalent fraction, we extend the line, put our equal sign, and in this case, we want to change our denominator to 12. Okay, to 12. So we want to make 12. So how do we get from 4 to 12? Well, we skip counted 4, 8, 12. So if we're skip counting, then we are naturally going to multiply. So 4 times what makes 12? Let's count it again. 4, 8, 12. Looking at your fingers, you should see 3. So what we do to the bottom, to the denominator, we must do to the top. So 4 times 3 on the bottom, 3 times 3 on the top. So 3 times 3, count by 3s 3 times, 3, 6, 9, 9 twelfths. So now we have 6 twelfths compared to our 9 twelfths. And remember, our 9 twelfths still equals our 3 fourths. So we're looking at this, same denominator, 12 and 12, 6 and 9. Now which one is the greater number? The alligator always wants to be the bigger one. What's bigger, 6 or 9? In this case, it is the 9. So 6 twelfths is less than 9 twelfths. So we rewrite it again, 3 fourths, 6 twelfths, less than 3. Oh, sorry. 3 fourths. Okay? So hopefully that helps you out in comparing ordered fractions. Remember, use your fraction strips to help you out. Okay? So the next image I'm going to bring up, and we're also going to be for this first lesson, is going to be also be looking for simplest form, and then we'll come back to working with equivalent fractions again. Okay? So let's take a quick pause while I change the slide. Okay, so our next task here is to find the simplest form of 6 12. So simplest form means we want to find the form in which both the numerator and denominator, they cannot be divided by any other number besides 1. So in order to find simplest form, we must divide. So simplest form, when you think about simplest form, when you think about simplest form, you should think division. Okay? Time you hear simplest form, think about division. So, let me fix that again. So think division for simplest form. Okay. So, looking at the first one, it says simplify 6 twelfths. So I'm going to take my 6, put it over my 12. Now remember, we're thinking division, so we're going to extend our line. I'm going to put equals. I'm going to divide the top, and I'm going to divide the bottom. And when I divide these, I want to ask myself 2 questions. The first question I should ask is, can the numerator, in this case, can my 6 go in my denominator? If yes, then I can divide by my numerator. So let's see, can 6 go into 12? 6 12. Yes, it can. So in this instance, I will use my 6. So 6 divided by 6, 12 divided by 6. So working my way across, 6 divided by 6 equals 1. 12 divided by 6 equals 2. Simplest form is 1/2. Okay? So that's how we would solve that. So simplest form is basically dividing. Now, if my numerator can't go into my denominator, then I have to find the biggest number that can go into both. So for example, here's another one. Okay, so here's another one. So let's look at this fraction. Okay, our fraction here will be 15 20ths. Now I ask myself, can 15 go into 20? 15, 20. No. 15, 30? No, it can't. So I've got to find a factor that will go into both of them equally. So extend my line. Okay, and remember, I'm going to divide both the top and the bottom. Think about it. What number can go into 15 and 20? Okay, if you said 5, you are correct. So 5, 10, 15, 3, and 5, 10, 15, 20, 4. So your answer will be 3 fourths. Okay, so that's how you would find simplest form. Okay, so our last problem set for today is actually finding an equivalent fraction. We'll go back, going back to the beginning of it. So find an equivalent fraction for 3 fourths. And so when we're finding equivalent fractions, okay, so we're looking at equivalent fractions. Instead of like simplest form where we divide in equivalent fractions, we want to multiply. So 3/4, I want to find an equivalent fraction for 3/4. Okay. Okay. Same steps. Extend our line. Equals. Okay. And again, we said we are going to multiply. So in this instance, any factor greater than 1 will give us an equivalent fraction. So if we multiply 3 times 1 and 4 times 1, we'll end up with 3/4 again. So we can't do that. So we've got to start with a number greater than 1. So first one that we wanted to try actually is starting with 2. So remember, when we multiply what we do to the top, we must do to the bottom. So we multiply our numerator by 2, our denominator by 2. So 3 times 2 gives me 6. 4 times 2 gives me 8. Okay, so let's try it again now. So I have 3/4, and I want to make an equivalent fraction that's not 6/8. Not 6/8. So mental math, really quickly, what would you multiply by? Okay, correct answer. Yes, you guys started at 2. You can go to 3, as long as it is not 1. So 3 times 3 gives you 9. 4 times 3 gives you 12. Okay, so that's how you would make equivalent fractions. Simple way. Now, if we have to find missing number, okay, we have to find missing number. So let's go here. So let's say we have 3/4, and we have our denominator as 12. We know we multiply, but we don't know what we multiply by. Okay, what we have is a question mark. Okay, we don't know what we do here. Alright, not too sure there, as well as here and here. How do we solve for that? Okay, so quick way that we can solve it is we look at our denominator. We know we're changing that to 12. We know equivalent fractions, we must multiply. So let's count by 4s up to 12. 4, 8, 12. Looking at your fingers, that's what? 3. So 4 times 3 will give me 12. So what I do to the bottom, I must do to the top. 3 times 3. Okay. Sorry, my 3 there. Will give you 9. Okay. So now let's tackle a little bit bigger problem. Okay, let's tackle a little bit bigger problem here. So I started out with 1/5. Okay. Oh, sorry. Do that again. I started out with 1/5. Okay. And I have to change that to, it has to equal something 100. So now in this instance, we know we're going to have to multiply by another factor, both the top and bottom, to get our numerator. But do we want to be counting by 5s all the way to 100? Most likely not. So what we do here is we use the inverse property when we've got to go to a greater denominator. So here's how we figure out for what our missing factor is here. Inverse property, remember, means the opposite. So we'll take 100 and we'll divide it by 5. So now let's count by 5 to 1. Can 5 go into 1? 5? No. So we go over to our next place value, which is our 0, which gives us to 10. So let's count by 5 to 10. 5, 10, that gives me 2. Okay, remember, multiplication, inverse property. 5 times 2 gives me 10 here. Subtract. 10 minus 10 gives me 0. Can 5 go into 0? Nope. So now I drop down by 0. Can 5 go into 0? Nope. So can I leave the place value empty? No. So nothing can work there. What's the number, the magic number that I can put in there? Correct. 2 or 0. So 0 times 5 gives me 0, and I subtract, and I end up here. So 20 times 5 gives me 100. So now I found my missing factor. So 5 times 20, 1 times 20, okay, gives me 20.